For the last part of the mean value theorem and second fundamental theorem of calculus notes, I want to talk about the net change theorem, which says that the definite integral of the rate of change of a quantity f prime of x gives the total change or net change in that quantity on the interval, which is essentially what we had been doing with the first fundamental theorem of calculus. Except here, our function is now f prime, but it's still the same thing as the first fundamental theorem of calculus, meaning integrate it. Now remember that integrals and derivatives are opposites of each other, so it would give you the original function, evaluate it from a to b. If we look at this graph here, displacement from an interval from a to b would just mean find the area here, find the area here, find the area here, knowing that area beneath the x-axis is negative, but total distance traveled from a to b would be the absolute value of these area totals, meaning that distance can't never be negative, so we would take the absolute value of this area and then add it to our area 1 and our area 3. So let's do an example. Particle is moving along a line so that its velocity is given by this function, feet per second at time t. What is the displacement of the particle on the time interval from 0 to 5? Well, displacement is just taking the integral from a to b of our function without changing anything. So if we were to integrate our function going from 0 to 5 of t cubed minus 9t squared plus 15t plus 10, that would give us, integrated and evaluated, that would give us a total displacement of 75/4 feet, or 18.75 feet, which essentially is the same thing. But now, what is the total distance traveled by the particle on that same time interval? Now we're talking about distance, which means we can't just integrate it and evaluate it, because if we look at our function, somewhere along the line we've got a negative area or a negative value. So what we need to do first is find our zeros to our function. Given that this is a cube, we can't factor it by grouping or by any other method that we know. So what we do is we graph it and then find the intersection point with our function and the x-axis. Well, that would give us some irrational roots. Let me state those here. We have negative 0.505, 3.083, and 6.422. And what we can do is, given that we have these irrational roots, we can now integrate. Keep in mind that we're going to go from 0 to 5 and make sure that it stays positive. So what we'll do is, well, we're not going to go from here because that's smaller than our 0, our starting interval. So we'll go from 0 to our next root, which is 3.083 of our function, which is t cubed minus 9t squared plus 15t plus 10 dt minus, we're going to go from 3.083 all the way up to 5 of the same function, 9t squared plus 15t plus 10 dt. And the reason that I broke it up into two intervals is because total distance is the integral of the absolute value. Well, the only way that we can do absolute value integrals is we have to find where it touches our x-axis and then find the area before that and find the area after that and combine the two. Well, the reason we're subtracting here is because this area would be below the x-axis. Distance has to be positive, so we're going to change it to go from a negative to a positive by getting this area, which is negative, multiplying it by another negative to make it positive. You integrate this, you evaluate it from our lower and our upper bounds, and that would give you a total distance approximately of 54.833 feet. I hope these videos have helped, and I will see you soon. Thank you.